Robert W. and Mabel Beg's lectureship on science, spirituality, and society, which is sponsored by Cornell United Religious Work and the Chesterton House, a chaplaincy of CURW. The lecture is named for a former CURW chaplain and his wife, Robert Beggs, who was a chaplain for an international ministry here back in the 1960s and 70s, and Mabel Beggs, who was the founder of the Foundation of Light Spiritual Center in Spencer. The Beggses were firm believers in the cooperation and understanding among diverse religions. It was following Mabel Beggs' death in 2005, she was predeceased by her husband. CURW received the endowment she and her husband had designated for this lectureship. Emphasis was to be given to ethics and public policy, comparative religions, and the interplay between science and religion. Reverend Beggs conceived of this lecture as hosting speakers that illustrated how science and religious spirituality can work hand in hand for a better world society. I am grateful for the hard work and support of CURW core staff members Janelle Hanson and Dan McMullen, and Carl Johnson, our chaplain colleague with Chesterton, to help make both this event and a CURW program in New York City last evening, at which tonight's speaker spoke to an alumni audience, possible. The speaker you will hear tonight has been one who has worked at the intersections of science, religion, ethics, and public policy, important priorities for the Beggses and their hope and aspiration for this lecture, regarding one of the increasingly contested and looming issues of our time and the time to come, climate change. There has been much debate in recent years over climate change. As a public broadcasting documentary featuring our speaker on Tuesday night indicates, public opinion has shifted from a majority of Americans polled in 2008 believing that climate change was occurring to much more mixed results in 2012. In those 4 years, a well-organized, well-funded, and multifaceted campaign involving political, private, scientific, and corporate interests, among others, have challenged scientific data, empirical evidence, and other factors that point to climate change. Our speaker tonight will help us to sort out many of the details of this debate and provide us a nuanced understanding of the realities and the dynamics of climate change. Katharine Hayhoe is Associate Professor in the Department of Political Science at Texas Tech University, Director of Texas Tech's Climate Science Center, and the CEO of Atmos Research, a scientific consulting company. She is a rising star in the field of climatology. Her research and contributions as an expert reviewer were part of a Nobel Prize-winning intergovernmental panel on climate change. She has presented her research and work in congressional hearings and has been covered by a number of major media outlets. In total, over 200 media organizations worldwide. She has been covered in the press in particular for her engagement of her specific faith community, evangelical Christians, regarding climate change. In Tuesday's PBS documentary, she said her faith defines her more than the work that she does. But she does not dichotomize between faith and work, affirming the intersectionality of both in ways in which, though that intersection connects up with other intersections related to her talk tonight. She is the author, with her husband Andrew Farley, who was a pastor and linguist at Texas Tech, of the book Climate for Change, Global Warming Facts for Faith-Based Decisions. We have copies of that book available for the very special price of $5 that we will have on sale for you this evening following the program. Tonight, Katharine will speak to us about Indeed, the topic of her book, her co-authored book, A Climate for Change, Global Warming Facts for Faith-Based Decisions. Let's welcome Katharine to Cornell.
I'm going to try to talk without a mic, so if anybody's at the back and you can't hear, there's a ton of seats available. Everybody knows what this is. But it wasn't until we actually sent people out in space that we could get pictures like this. How we think about this planet, suspended in the middle of empty space, has enormous implications for what we're going to do with it. So what I want to show, first of all, is that according to most people's values, conserving the Earth, caring for the planet, protecting the planet, is not the sole domain of, pantheistic, godless, liberal tree huggers that join Greenpeace. And I can say that with love because I have many friends who are exactly in that category. But there tends to be this bias, this perception that those are the only type of people who care about the Earth. I think that's completely false. For most of us, thinking about the Earth as something valuable, something we want to take care of, is very consistent with the values that we already have. So I want to start off by looking at some of those values. I'm a scientist, so I'm going to start with the science. What does the science say about the Earth? The science says that we're on the third planet from the sun. The sun is a relatively unimportant star in a branch of the Milky Way, but given the fact that the Earth and the sun and the Milky Way itself are in no way spectacular, we are incredibly unique. As far as we know, the Earth is the only home to life in the universe. Now, just for the record, if I was a scientist who was involved in the search for extraterrestrial life, I would stop, because someone said very sensibly, there's a 50-50 chance they're smarter than us, and you don't want to find the ones that are. But we're not going there today. I don't like alien movies. What does the Bible say about the Earth? I'm a Christian myself, so the Bible is where we go to get our values. The Bible says a couple of things. It says that the Earth is God's creation, given to humankind to rule over and subdue. Most people interpret that as being stewards or caretakers of the Earth. We're also told in Romans that creation reveals the nature of God. It's an expression of God. If we look at other world religions, we see some interesting things. If we look at Islam, it says that people are God's agents on earth, that God created nature in a balance, and it's our responsibility to maintain that balance. We're to walk on the earth with humility. Buddhism says that everything depends on each other, that humans are not separate from the earth, and the world is not separate from humans. We coexist together. So, what I would argue is that science and many major world faiths and religions agree that the Earth is a unique and special place worth caring for, and frankly, anybody who lives on the Earth I think should agree, because without the Earth we wouldn't be here. Unless your dearest wish is to move to Mars, the Earth is all we have. So it just makes sense to make sure that that we can maintain it. It's kind of like your house. It's even like your body. Everything that we have, that we use, we want to make sure that it's clean, that it's well taken care of, that it's comfortable, because that's where we live. So where does this whole story of climate change begin? It begins, I think, with energy. We've been using energy for a long time, but it wasn't until the Industrial Revolution that we figured out how to dig massive amounts of coal and gas and oil out of the ground and burn it. We mine for coal. We are increasingly fracking for gas. And we build these platforms out in the middle of the ocean to dig up oil from deep under the sea. The problem with all of this boundless energy that we've been using over the last few hundred years is that it has fueled a consumerist society, and with our consumerist society comes an enormous amount of waste. So at the same time, we have garbage dumps that are enormous. I originally come from Toronto, and for a number of years we were actually selling our garbage to Michigan. We did not want to keep it in Ontario, so we paid Michigan to take it away. So there would be these convoys of garbage trucks just going down the 401 all the time. Plastic is a big problem because it doesn't break down very easily. In the middle of the Pacific Ocean, there is a patch of plastic twice the size of Texas. It's just collected there because of the way the ocean circulates. People can go through it in ships, and it's just amazing to look at the collection of garbage out in the middle of the remote ocean that we have made. If you go to the tropics, large areas in the tropics have been deforested over the last couple of decades. This is what clear cutting looks like. It's naked. Here in the US, in Appalachia, you have mountains that originally look like this that are literally having the tops cut off. I remember the first time I saw this, I was actually flying, I was in grad school at Illinois, and one of my friends was in the flight club, and he had a brother and I had a best friend at Duke, so we decided that we were going to fly down together in this tiny little Cessna airplane. I'd never been in a Cessna before. So we're flying there, we're halfway there, he says, well, we have to stop for gas, and I said, well, where are we going to stop for gas? We're in the middle of here. He says, oh, don't worry, there's an airport coming up. Sure enough, he goes in, and all of a sudden there's an airport on the top of a cut-off mountain. It was the weirdest thing in the world because you're flying along at exactly the same height. We just flew right up to it and landed. And then you just took right off again like that. I have a small child, and anybody who has a small child, especially between the ages of 2 and 3 and 4, you spend a lot of time with a certain activity. And I think that this certain activity is actually very analogous to what we're doing with the earth with all of our waste. If you do not yet have the small child, you have this to look forward to, many, many hours of this. In many ways, what we're doing is obvious. This is a look at pollution over a major city. Are we able to turn these lights out right here, or does that send the whole thing out?
It's all or nothing.
It's all or nothing, okay. Yeah. Is that better?
Yeah.
Okay, let's do that so you can see the pictures, and then you can look at my face later after we're done. In many ways, the pollution that we're creating, the garbage, the waste that we're creating is obvious. You can see the big plastic patch in the middle of the Pacific Ocean. You can see the clear cutting that's happening in the Amazon. You can even see the air pollution over major cities. But more insidious than the things we can see with our own eyes are the things that we cannot see with our own eyes. What you're looking at here, what you can see is you can see the steam coming out of a power plant. You cannot see the carbon emissions. They're invisible. We cannot see them, we cannot smell them, we cannot breathe them. But despite their invisibility, they are creating a problem. What is this problem? The problem is that every time we burn a carbon-containing fuel, in this case, this example shows natural gas. And don't worry, this is the only chemistry we're going to get into. Every time we burn a carbon-containing fuel, it combines with oxygen from the atmosphere, and it produces carbon dioxide. Carbon dioxide is a heat-trapping gas. Not only have we measured increases in carbon dioxide in the atmosphere, that's the black line, we have actually measured decreases in oxygen. Because when you burn the fuel, it combines with the oxygen. So our carbon dioxide levels are going up and our oxygen levels are actually going down. Not enough that it would make a difference for us to breathe, so don't worry about that. But it's confirmed that this is what's happening. We're burning these fuels, it's combining with oxygen, and it's producing more carbon dioxide. We have really good records of how much coal and gas and oil we've been using over the past few hundred years because you pay money for it. And anything that we pay for gets written down. So we know that since the 1800s, we've been using increasing amounts of these different carbon-based fuels, and as we've been using them, they've produced more and more carbon dioxide. You can measure it coming out the smokestacks of our factories, you can measure it coming out the tailpipes of our cars. If you look around the whole world, we see that the US is actually one of the biggest producers. This is adding up all of the carbon produced over the last century. And what you see is there's some countries that have produced almost nothing, and there's other countries that have produced quite a lot. Now, if you showed this map on a per-person basis, then there's many other countries like Canada and Australia that look just as bad as the US because per person we use just as much energy. Here in the US, about 1/3 of our energy comes from industry or is used, I should say, in industry and manufacturing. About a third of it is used in transportation, not just personal transportation, but also transportation of goods. About a quarter of it is used in heating and cooling our homes and our personal energy use. And then a remaining 20% or 18% is used in commercial buildings, office buildings, not Target specifically. I'm not picking on Target, it just the colors just matched. I like Target. Or Target, as some people say. So why are these gases a problem? Well, to figure out why they're a problem, we have to go back to look at our atmosphere. What makes our planet so unique is that it has this incredible atmosphere. If it was not for our atmosphere, our planet would be a frozen ball of ice. We have an atmosphere that keeps us almost 60 degrees warmer than we would be otherwise. Our atmosphere acts just like a blanket does on a cold night. How does a blanket or a comforter keep you warm? It traps your body heat, right? That's exactly what our atmosphere does. Our atmosphere is made up of gases that are almost transparent to energy from the sun. Those are those yellow lines there. So the energy from the sun goes straight through our atmosphere down to the earth where we need it. And then the earth absorbs that energy and re-emits heat. It turns out the atmosphere is quite opaque to heat. It absorbs it and it traps it and it keeps it close to the earth where it keeps us nice and warm instead of freezing. Now, this is an entirely natural phenomenon. It's driven by natural levels of heat-trapping gases in the atmosphere. These include carbon dioxide, they also include methane, and they even include water vapor. So what does this have to do with people? This is a good thing. We wouldn't be here if it wasn't for this. Well, we all need food, we all need water, we all need vitamins, we all need these things to live, but what happens when we have too much of a good thing? Too much food can lead to obesity problems, especially too much of the wrong food. Too much water can kill us. Too much vitamins can actually make us sick. So what we are doing is we are adding an extra layer of blanket to our atmosphere. And so it is trapping more heat, artificially enhancing this natural effect. It's kind of like when I was little, I used to stay at my grandma's house. And she had this fear that I would freeze to death. Don't ask me why. So every time I would go to sleep at night and I'd be fine, and I'd wake up in the middle of the night sweating because after I went to sleep, she'd sneak in and she'd put an extra blanket on me. That's what we're doing to our atmosphere. We are sneaking in and we're putting an extra blanket on it, and the atmosphere is heating up. Now, 1.5 degrees doesn't sound like a lot. There's probably a 1.5 degree difference between this room and that hallway out there. But what we have to realize is that the temperature of our planet is as stable as our body temperature. Yes, it can go up and down from place to place, but on average, the temperature of our planet as a whole is extremely stable. It goes up and down by maybe 0.4 degrees Fahrenheit from year to year. I know my body temperature goes up and down by that over the course of the day too. So what happens if our body temperature increases by 1.5 degrees? You don't run for the emergency room. You know, it's not an emergency, but it's a warning sign. It's a warning sign that something is off. Something is not quite right. You might kind of check your throat. You might take a Tylenol. You might kind of take your temperature a few more times to see if it's changing, if it keeps on going up. Because if our body temperature goes up 1.5 degrees, that's a warning sign. And because our planet's temperature is just as stable as our body, when it goes up 1.5 degrees, it's a warning sign. And this is exactly what we've seen. If you look at our planet, it wasn't until about 1850 that we had enough weather stations all around the world to actually calculate a global average. The first weather station started back in 1659, but it was the first one. There was only one. Then they added another one, then they added a few more. So by 1850, we had enough weather stations around the world, a couple of thousand weather stations, to calculate the global temperature. And what we see are two things. We see, first of all, that from year to year, our temperatures go up and down. That's weather. We all know about weather. Next year could be colder or it could be warmer. That's just weather. But the second thing we see is that over the long term, over climate timescales, climate is the average over at least 30 years. Over climate timescales, we see that our temperature is increasing. to the point where the 2000s were the warmest decade on record, and 2010 tied as the warmest year on record. 2011 was the warmest La Nina year on record, because usually a La Nina year is pretty cool, but it was the warmest one we've ever seen, and this year so far is on track to break the 2010 record. But if you look at this, you can see we're not going to break a record every year, because that isn't the way it works. It works over decades, not from year to year. So the question we have to ask then is, well, you know, yes, we've been increasing carbon dioxide levels, yes, we've been adding an extra blanket to the planet, and, you know, yes, our global temperature is increasing, but how do we know it's people? How do we know it's us? This is where, you know, you can even bring a spiritual argument to it. Like, if God is in control, how could he let this happen? People really aren't that important. Isn't it egotistical to think that we can affect something as big as our planet? Only God could do something like that. We're usurping the role of God. So there's a lot of spiritual arguments we can bring in to say, even if this is happening, it can't be us because God wouldn't have set it up that way. Well, I'm sure you can think of many examples in your lives that God has set up that we can do an enormous amount of damage to. It's an eternal debate, predestination versus free will, but I think we would all agree that we all have free enough will to make some very bad decisions, and the Bible is very clear that when we make very bad decisions, we reap the consequences. If we drink excessively and we get behind the wheel of the car, God does not usually miraculously direct us into a telephone pole instead of some more valuable property or even a person. It's because we made a bad choice to do that. If we make bad health choices, we reap the consequences of those. There's all kinds of examples of ways that we've made bad choices and there are consequences to those choices. But you could still ask, you could still say, well, here's the thing though. Our climate has changed in the past. We know that. It has. You know, there was evidence for ice sheets covering Canada, all these lakes we have here, the Finger Lakes were scoured out by the glaciers thousands of years ago. So isn't this just another natural cycle? And we do have to look at that because we have to eliminate the natural cycles first before we can actually say, well, this time humans are controlling climate. Because that is a very egotistical thing to say. So let's start with the sun. The sun is where we get all of our energy from. Just about all. We get a little bit from the geothermal energy from the inside of the earth, but most of it comes from the sun. So in the past, when it's gotten warmer, it's because we got more energy from the sun. When it's gotten cooler, it's because we got less energy from the sun. So we have to look at the sun and we have to say, could the sun maybe be driving most of this warming? And just coincidentally, we've also been producing more carbon dioxide. When we look at the sun, this is what we see. The sun has this 11-year cycle. We can see it in the sunspot cycle. That's the thin purple line. I'm glad we turned out the lights. It's a lot easier to see the thin purple line. And then the thick line is the long-term average over that 11-year cycle. Then the orange line is our global temperature that we just saw before, and then the thick orange line is just the average of the global temperature, the average trend. What we see is that until the 1970s, we were getting more energy from the sun and our temperature was going up. But what's happened since the 1970s? Energy from the sun's been going down. So if our temperature were being controlled right now by the sun, it would be getting cooler, not warmer. The sun cannot be responsible for our current warming. Well, what about natural cycles? We all know about natural cycles. Here in the Northeast, you might have heard of the NAO, the North Atlantic Oscillation. It has a big impact on winter snowfall in the Northeast. In Texas, we care a lot about El Nino because it has a huge impact on how much rainfall we get in West Texas. So couldn't it just be one of these cycles? There's so many different natural cycles. Couldn't it be one of these? We have a way to test for that. And that's because these natural cycles are part of the Earth. They're inside the Earth. They don't come from outer space. They're part of the Earth. And what they do is they shift heat around. They move it from the atmosphere into the ocean, or from the ocean into the atmosphere, or from the southern hemisphere to the northern, or from the northern to the southern. You get the picture. They can't create heat, they can't destroy heat, they just move it around. So if our atmosphere were warming because of a natural cycle, where would that heat be coming from? It would probably be coming from the ocean. So let's look at how much the heat content of the ocean and the atmosphere has changed over the last few decades. The green line here is how much the atmosphere and the land and the cryosphere, that's all the ice on the Earth's surface, how much heat they have absorbed, and the blue is how much heat the ocean has absorbed. The ocean has absorbed 20 times more heat than the atmosphere. So there's no way this could be an internal natural cycle. It would violate the fundamental principle of conservation of energy. It can't be a natural cycle. Everything's getting warmer at the same time. There is no cycling happening. Well, you might say, okay, but aren't there some other natural cycles, like the ones that happen over long periods of time that made us, made the ice sheets and then gave us the warm period we're in right now? Here's the thing, though. According to those cycles, this is our temperature over the last 6,000 years. What we see over the last 6,000 years is we were going down. And there was a paper published just this year that said, what is the natural length of our current warm period? And interglacial is the name for our warm period we're in right now, as opposed to an ice age. They said that based on natural cycles, our current warm period should end within 1,500 years, which for geologists is like that. Geologists think that 1,500 years, like literally the blink of an eye. So what this looks like to me is that we were headed for an ice age until what happened? Until the Industrial Revolution. We have interrupted a natural cycle. The natural cycles are still at work, absolutely. But for the first time, if you think of it kind of like a car, humans have been riding in the back of the car for a long time, as long as we've been around. But over time, we've slowly been moving up. And when the Industrial Revolution came along, we climbed up in the front seat, we elbowed the natural cycles out of the way, and we grabbed the wheel. They're still riding along with us, but we are actually steering the car for the first time. How do we know for sure that it's us? The problem with doing climate science as a physical scientist is that we can't put the Earth in a test tube. We can't put it in our lab. So imagine if we had another Earth that looked just the same as our Earth, but it didn't have any people on it. And that Earth was not getting warmer, or maybe it was even cooling, and our Earth was getting warmer. Then we know for sure it had to be people, right? Unfortunately, we don't have that other Earth, and all of our prayers have not yet given us that Earth. So what we've done instead is we have used the most powerful supercomputers in the world and all of the physics and chemistry and biology and mathematics that we know of to create a virtual Earth. Into these virtual Earths, which we call climate models, we put everything we know about the physics of clouds, the dynamics of ocean currents, the way vegetation and plants interact with the atmosphere. Everything we know about the climate system gets put into these models, and with these models, we can actually create a world with no people, and here's what it looks like. This is the real temperature of our Earth. As you can see, it's smoothed out to just look at the 10-year averages. This is the real temperature of our Earth, and this is the temperature of the Earth with no people. This Earth has volcanic eruptions, natural cycles, changes in energy from the sun. It has all of those natural causes of climate change in it. And according to that, we should be getting cooler. Now we take the exact same model with all of the natural causes and natural cycles in it, and we make one change. What is that one change? You can probably guess. I'm going to go back here and show you that one change. The one change is we put this into the model. That's the only change. And when we do that, this is the penalty for jumping around your slides. You're always going back and forth. When we do that, this is what we get. There is no way to explain the warming over the last 50 years if we leave humans out of the equation. We literally cannot explain it. So the natural corollary to this, the natural, where do we go from here is, well, if our emissions are driving future climate change, then driving current climate change, the amount of future change must depend on the choices we make. And that is exactly what we see. If we could somehow magically turn everything off today, which I do not think is a good idea, by the way, if we could somehow do that, then we would still be looking at one more degree of change. That's the green line, just because of what we've already put in the atmosphere. It's kind of like if you have had a long history of eating very poorly, and never exercising or taking your vitamins, and then you kind of go cold turkey and you're eating really healthy and you're exercising, you still have some lingering health effects, right? If you had 30 years of not doing the right thing. So in the same way, we'd still have some lingering health effects of all of our years of carbon emissions, even if we could switch everything off today. If we continue to depend on fossil fuels as our primary energy source, we're looking at the higher orange end. If we can, in a sustainable and sensible way, start to reduce our dependence on fossil fuels and transition our energy to other sources that are cleaner, then we'd be looking at the lower scenario. But the problem with this is that you're still looking at global temperature. And frankly, 10 degrees sounds like a lot, but there's a 10-degree difference between this hall and outside the window. So this really doesn't compute in terms of a problem that matters to us, because 10 degrees just doesn't sound like a big deal. I mean, my husband likes the house 10 degrees colder than I do. We fight over 10 degrees on the thermometer all the time. I'm Canadian, so I like it warm actually, and he likes it cold because he's from the south. Not only that, but if you ask people what's going to happen because of climate change, name one bad thing that's going to happen because of climate change, you know what people's #1 answer is? The polar bear. And it's not that we don't love the polar bear. Although actually, an ecologist told me the other day, she said, polar bears are nasty animals. Do you know how nasty they are? She said if people knew that, they wouldn't even look at the polar bear. But we think of the polar bear as kind of that's what's going to be impacted by climate change. And, if somebody came up to you on the street with a survey and said, would you preserve the polar bear? I'd probably say, sure. And then they say, well, would you pay $2,000 more for your car to preserve the polar bear? And I'm going to be honest with you, I'd say no, because that's hurting me in my wallet. There's many other concerns that I have. So we have this picture of climate change being this thing that happens in the distant future, #1, and #2, affects things that don't really matter to our lives today. And so what I want to show you right now is I want to show you the results of a study that I did with people here at Cornell. My colleagues Art DeGaetano and Dave Wolf and I and about 50 other scientists looked at how climate change would affect specifically the Northeast. No polar bears, no penguins, no ice, just the Northeast. Why should we care about it if this is where we live? Well, here's what we're seeing. If we look around the United States, extreme rainfall is already becoming much more common. This is not anything in the future. This is what's happened over the last 60 years. If you've lived in the Northeast for a long time, if your parents have lived in the Northeast, you know there's a lot more flooding now than there used to be. And it's true. There is 67% more heavy rainfall events now on average than there was back in 1950 when they started counting. And that's because as the air warms, there's more water vapor. When a storm system comes along, it gathers up all that water and dumps it. That's what's happening. It's physics. The Northeast is already seeing warmer temperatures, especially in the winter. Our winters here have gotten a lot warmer than they used to be. If you think there's less snow now, you're right, there is less snow. Because more winter days have rain and less are having snow. In the future, the amount of change here is going to depend on the choices we make. Remember, if I go back again, I'm going to risk it. Here we go. Remember the higher and the lower ones here? The orange and the blue? That's exactly what I'm showing you now in these thermometers. Here we go. Over the near term, our choices don't really matter because the change is responding to what we've done over the last 30 years. Our choices that we make today, we're going to see the results of in 20 or 30 years. That's why this is so tough. It's really tough because whatever we do today, we won't see the difference until 20 or 30 years from now. And we care about those things. We plan for our future, we plan for our children's future, but we have a political system that looks 4 years down the road. Maybe even less, you could argue. They look 2 years down the road. So it's a really challenging problem because whatever we do today, we will not see the results of for 20 years. But here's the problem. When you start seeing the results, it's too late to fix it. It's kind of like being on the operating table, ready for your quadruple bypass surgery and saying, you know what, doctor, I've changed my mind. I'm going to reform, I really am. I promise you I will. The doctor's like, well, that's great, but we got to do the surgery right now. It's too late. You already made the 30 years of choices that brought you to that operating table, and then you can't do anything. So in a way, climate scientists are kind of like doctors, I feel like. People say, well, you know, why bother telling people about climate change, especially if you live in Texas? I mean, frankly, these days, being a climate scientist talking about climate change in Christian or conservative or Republican circles, you kind of feel like, you know, one of those soldiers in World War I who stuck their head up out of the trench without their safety hat on. That's what it feels like. You barely have time to utter one sentence before you get shot in the head. So people say, well, you know, why bother? And a lot of my colleagues have said, why bother? It's just not worth it to me. I do it because I feel like it's similar to what a doctor does. A doctor can, these days, they can do one of those, you know, full body scans. You heard about those, where they can scan your whole body, or they can like test your genomes to figure out what hereditary diseases you might have. And then they can tell you the early warning signs of things you might want to watch for. So imagine if you went to a doctor and they did a scan and they found the beginnings of possibly a tumor or the beginnings of some type of disease. They caught it early enough that it was treatable. But telling someone that they have a problem is bad news, right? And the doctor's like, oh, well, I don't want to tell them that they have a problem because they'll get angry at me and they might get mad at me and, you know, they might even complain, so I'm not going to tell them. I mean, how ridiculous is that, right? The doctor has a moral responsibility to tell people if they find something wrong. So in the same way, climate scientists are the ones who are doing the full body scans of the planet. We are finding that there's something wrong. We're running these future scenarios to say, what if we continue our current consumption patterns versus what if we take a different pathway into the future? We're generating this information. I feel like this is information that we as a human race need to make sensible decisions using the brains that God gave us and the free will as well. So what else does it mean for the Northeast? This is an interesting thing that we did. This is upper state New York. You'll recognize the shape of it. It's upper state New York. We said, what would the summers feel like under the lower emissions or under the higher scenario? The higher, again, is where we depend on fossil fuels for the rest of the century. The lower one is where we transition slowly over to other sources of energy. So this is the heat index. You guys all know about the heat index, right? It's the heat plus humidity. It's how hot it feels in the summer. So this is how hot a typical summer in upper state New York would feel under lower emissions and under higher emissions. And I don't know about you guys, but there's probably a reason why you decided to live in Ithaca as opposed to Baltimore or Richmond or even Charlotte. It's because summers in those places are a lot different than here. And so I like this because it gives us a very kind of visceral feeling of what climate change would do to upper state New York. You just have to go to one of these places in the summer and you can say, imagine Ithaca feeling like one of these places do in the summer. Places that I might add all have central air conditioning. I'm from Toronto myself. I didn't have a car with air conditioning in it till like 10 years ago. Our whole family just had cars with no air conditioning. My parents didn't have air conditioning in their house. We didn't need it. Now we do, but there's some big changes that we have to make. This is showing something specifically for Buffalo. Buffalo currently has 1 day over 100 every other year. It has like 1 day over 90 every year, I think. Doesn't even show up there. So this is showing the projected increases in days over 100 and days over 90 degrees under the lower and the higher future scenarios. We see some pretty major increases in extreme heat. What about our winter snow? This red line shows the area in the Northeast that has at least 30 days of snow cover per year. And this is showing the average from 1961 to 1990. So even today, that red line has changed. And then the white area, unfortunately, this is only higher. I didn't have the lower on this map. The white area shows what would happen under the higher emissions by the end of the century, the higher scenario. Massive changes. I mean, this is a huge change to the Northeast. So if you want to know more about the specific study that we did, like I said, with people from Cornell, you can get all of this information at climatechoices.org. It's freely available with lots of pretty pictures. I can take no responsibility for that. I just helped with the science. But just for perspective, so these are the things we're concerned about here. We're concerned about heat stress on cows and livestock. We're concerned about damages to our fruit crops. We're concerned about things shifting northward over the border into Canada because it's too warm to grow them here, which has already happened to blueberries in Maine. But if you look around the world, we also have problems like sea level rise. We expect at least a few feet of sea level rise this century. That means that Bangladesh stands to lose half of its rice-growing area. We also stand to lose half of the Everglades and much of the Keys. Up in Alaska, the ground is melting and crumbling into the ocean. Permanently frozen ground is now melting. Sea ice is coming later in the year, so the powerful autumn storms pound the coast, ripping pieces of the land into the ocean that would otherwise be safely protected by ice. The U.S. Corps of Engineers, not exactly a reactionary or alarmist group, have estimated that there's almost 300 Native American villages that are at imminent risk. And when I say imminent, I mean that kind of imminent risk. I worked with one village called Kivalina. This here is actually Kivalina. They lost the school principal's house into the ocean while I was working with them. They lost their airport strip. They had to move, but they didn't have the money. They didn't know what to do. There's a lot of other things that are melting too. Our glaciers are melting. Some of my favorite pictures are pictures of what the glacier used to look like and then what it looks like today at the same time of year. This is one of the glaciers that supplies the city of Lima, Peru. Lima gets 2 inches of rain a year. 8 million people survive on 2 inches of rain a year. How do they do that? They do it because they have these glaciers. Some of the meltwater from these glaciers runs through irrigation channels built by the Incas. That's how long people have been depending on glaciers. But now that glacier is so far back that it's almost gone, and so a few years ago, Lima actually built a desalination plant so they could at least have drinking water. But desalination is a lot more expensive than free water. Around the world, there's 1 billion people that depend on water from glaciers. Right now, they have all they need, plus some. Soon, they'll have a lot less, and most of these people live in South America and Southeast Asia. Not exactly places that have a lot of extra cash lying around to build desalination plants. So we looked at this map before of what nations are producing the most carbon dioxide emissions. I have a different map. I have a map of which nations are most vulnerable to changes in climate. It's pretty much a mirror image. So what do we do? What can we do? Ken alluded to this. He alluded to the fact that Gallup has been asking people in the US whether we think the seriousness of global warming is exaggerated. They've been asking people that for 12 years. Over the last 3 years, we have seen an all-time record high number of people thinking that global warming is exaggerated. It's not a serious issue. It's no big deal. It's nothing that we need to worry about. If you break this out, you can see that these perceptions tend to run along party lines. All of the changes have happened on one end of the political spectrum. We can't exactly blame politics here, not only politics, because the Pew Foundation said, well, we're going to ask people based on what church they go to. Here we go. They asked a slightly different question. They said, is there evidence the Earth is warming? And they gave people a choice. The dark green is yes because of what people are doing, because of human activity. The light green is yes, but it's just natural. Then you have the kind of light brown that's yes, but we don't know. And then the brown is no, it's not warming. So the brown is people who say it's not even warming. Then the middle is people who say it is, but we don't know. And then just the far end is the people who say it is because of humans. So if you look down here, there is a progression from people who are not affiliated with any church, down to, at the very bottom, the group that I'm part of myself, which is white evangelical Protestants. We've got about 1/3 of the people saying that it is because of human activity. So that's the good news. There's 1/3 who say yes. The bad news is there's 2/3 who say no. Some colleagues of mine at Yale did a really interesting study called the 6 Americas. They divided people into groups based on how they felt about climate change. Are you alarmed? Are you concerned? Are you cautious, like, we need more information? Are you disengaged, like, it just, that's not part of my life. I don't really care. Are you doubtful, or are you flat out dismissive? And what they found is that in the middle, cautious and disengaged people had traditional religious views, mainline denominations. Over in the doubtful and dismissive were people with more conservative views. They were certain that global warming wasn't real. So here's the question. does the science of climate change conflict with Christian theology? Is that why people are rejecting this? Is because it actually goes against our statements of faith? I say no, absolutely not. Christians believe that God created the earth and that it's good. And most Christians, except for a very tiny sliver of what is called dominionists, most Christians believe that we have the responsibility to steward or care for God's creation. Not only that, but just about everybody on the planet, in their right mind, agrees that the earth sustains our physical existence and that it's important to conserve our natural resources. We might not do it, but we all think it's a good thing to do. So, why is there this conflict? Well, there's a couple of different reasons. Let's see. Here we go. I've got all the reasons up. And I'll organize them into a few different kind of headers. So I'm going to start with science first. It's kind of the easiest to break down. Lots of the more obvious effects of climate change, we don't really think that we can see them in our backyards. We look at our backyards and the sky is blue, the grass is green, there's water in the lake, it looks okay. It isn't until someone points out, you know, when did your tulips flower when you first planted them? And when are they flowering now? Oh, they're flowering 2 or 3 weeks earlier in the year, aren't they? How many heavy rain events did you used to get? And how many do you get now? How often is your basement flooded? Oh, it's flooded a lot more now, hasn't it? So we actually can see these things, but often until someone points them out, we aren't aware of them. What we also see is counterintuitive and hard to explain, and that's this picture here. This picture illustrates something that's really cool. This is at the cutting edge of climate science. This is what people are excited about today. We're figuring out how record ice loss in the Arctic is actually affecting our weather patterns over North America. In fact, you know the big storm that's supposed to be heading right for Washington, D.C.? Anybody been watching the hurricane? Yeah. The reason why, it's normally the hurricanes head out like that, right? That's their track. The reason why it's being guided back in is because there's a huge high pressure system over Greenland because the Arctic was so incredibly warm this winter, or this summer. We lost more Arctic sea ice this winter than ever before. It's so warm up there, there's this big high pressure system that's steering the storm right back into Washington. So our weather here is being affected by what happens up in the Arctic, but that's not that easy to explain. And then last, I'm going to be really honest with you, climate scientists are typically not the best communicators. I'm not saying that off the top of my head. Last year, this past year, in January, there was a journal article published by some psychologists who did personality tests on about 1,000 climate scientists and concluded that climate scientists have personalities that tend to be quite different than the average population. Not only that, but they have personalities that render them categorically unfit to talk to people in simple terms. Explains a lot, doesn't it? But the bad news is when they do surveys of who do you trust to tell you this stuff, scientists come out as the #1 most trusted source. So we trust people who literally can't talk about it. That's not good. That's a problem. There's more to it than that, though. There's psychology. This time we're the bad guys. Remember that map I showed you of the different countries? What did you feel when you saw that the US was red? It doesn't feel good. It feels like, man, you know, what can I do about that? It's already done. We're screwed, you know? Like with the war on terror, we're the good guys. But with this one, we're the bad guys, and that doesn't feel good. Thinking about big problems like this are difficult. It's harder to admit the reality of a problem than admit that we're helpless. What's the first step in AA? It's admitting that you're alcoholic. What's the first step in all those interventions that people do? It's admitting that there's a problem. What's the first step in becoming a Christian? The 4 spiritual laws? Admitting you're a sinner. It's hard for us humans to admit that we have a problem, and this really plays into this. And then not only that, but we are very afraid of the solutions to climate change. In fact, let's see. Let me go here right now. Where did I put that slide? Yes, here we go. It's really interesting because I was reading a book on the American Revolution to my son the other day. And reading that book, it really struck me how the revolution was based on taxation and government control. That is what spawned the revolution. What do we see when we talk about climate change? We talk about carbon taxes. We talk about government regulations. That's what America was founded to get away from. People have an instinctive, innate desire to avoid those things, to fight against them. For generations, that's what people have been doing in America. So I think that a lot of the proposed solutions, and I'm not saying there aren't other solutions because I do think there are, but a lot of the proposed solutions tend to push our buttons. And we react very strongly to that. What else? There we go. We also have this. There's a lot of confusion over climate change, and some of it is deliberate. It's really fascinating to me. I am not a conspiracy theorist. I hate conspiracy theories. Like, my husband is a friend who just goes on and on about like the particles from the military and all that kind of stuff, and I'm just like, oh, save me. So I'm not a conspiracy theorist. My husband's about to climb out the window after about 2 hours. He has more patience than I am. But the reality is that people have, some science historians have actually followed individual people and found that the same people who were hired by the tobacco industry to deny the reality of the connection between smoking and lung cancer, those exact same people have been hired by big business today to deny the connection between our energy use and climate change. Same people, same playbook. They literally just crossed out tobacco and then put in climate change. So there is actually deliberate attempts to confuse us, and what I really resent is the fact that a lot of these attempts are focused on the community I'm part of. That's where a lot of the effort goes into. Not only that, but we've gotten to the point now where denying the science has become an article of faith, essentially for many churches even, or even for your family, or to belong to a certain political party. What are our trusted sources telling us? Well, in 2010, about half of the representatives explicitly said that humans were not causing climate change. I mean, I'm not talking about people just not being sure. They actually made a statement about this to make it very clear where they stood. A Lifeway survey found that, this is the Pew survey that we just looked at, 66% of white evangelical Protestants don't believe there's evidence that the earth is warming because of humans. A more recent survey of pastors found that 72% of pastors don't agree. So, I mean, who are we listening to? We listen to the people that we respect. We listen to our leaders, and this is what our leaders are telling us. And, of course, more recently, we have 100% of Republican presidential candidates. And I'm not talking about the one, I'm talking about the whole stable of them. Even ones who, during the campaign, said, call me crazy, but I think climate change is real, you couldn't see their dust for taking back their words. So here's the problems. We have problems with the science, we have problems with the psychology, and we have problems with our leaders. We're just not getting the information. The people we trust are not giving us the correct information. So if that's the case, if we have all of these problems, why should we care? And this is where we have to leave off the science. And this is why I'm so glad to give this talk on science and spirituality, is because the science can only take us so far. And we have gotten to the end of the science now. From here on, it's about our values. It's about the things that matter to us, the values that we have today. We cannot instill new values in people. By the time we're 20 years old, our values are there, they're formed. So what are our values that we could use to help us make decisions about what to think about this issue? I mean, for me, I go back to the Bible, and in the Bible, there's some very helpful verses. Everything is permissible, but not everything is beneficial. In other words, you can do it if you want, but you might not like the results. Very sensible. Whatever we sow, we are going to reap. There are consequences to the choices that we make. But we're also told some positive things. We're told that we have one commandment now. We have one commandment that sums up all of the old rules and regulations that the Israelites had to struggle with for so many years. Our one commandment is this: to love our God and to love our neighbor. And so today, if we look around the world, we see that we've got rising sea levels that are flooding major cities in developing worlds. We've got widespread drought. We've got rapidly disappearing glaciers. They're threatening millions of people with loss of their water, their food, and their livelihood. So today it's our global neighbors. It's the people who are the poor and the disadvantaged who are most vulnerable to harm. So if we're going to love our neighbor, how can we love our neighbor through this issue? There's a very good quote that I like. This is a quote by John Holdren, who's, I think he's still the president's science advisor. I'm not sure. He said, we basically have three choices. We can mitigate, which is reduce our emissions. We can adapt to change. As change happens, we can adapt. And we can suffer. We're going to do some of each. The question is what the mix is going to be. The more mitigation we do, the less adaptation will be required, and the less suffering there will be. How do we make these choices? We make them based on our values. And that is why our faith is so important to us, is because that is where our values come from. That is where we have the foundation, the core, to look at issues like climate change and many other difficult issues we face through life and decide what to do about them. It got fancy on me. So how can we respond? We've got these scarce resources and we've got poverty. Tackling these problems, which we already do very well, World Vision, Food for the Hungry, Samaritan's Purse, Compassion International, I mean, we have all of these organizations who are working with people out of love, and people support them out of love. But they know that today, trying to address poverty, even education, even water shortages, without addressing climate change is like pouring money into a bucket with a hole in the bottom. The hole is climate change. We can't address one problem in isolation anymore because climate change is exacerbating all the other issues we're already dealing with. Climate change is not creating new issues. In most cases, it's just interacting with the problems we already have. And so for that, if we go to Glaciers, it tells us that the only thing that counts is faith expressing itself through love. And to each of us, that might mean a different thing. What can we do about it? It's always hard to kind of leave off at this point. So what are some things that we might be able to do? What if we decide to use our energy more efficiently? Use less fossil fuels and transition to renewable energy. We would cut our air pollution. We would improve our health, we would improve our children's health, we would improve our productivity. Somebody actually calculated that only for reasons of air pollution we shouldn't be using coal because we pay so much money in illness, lost work days, public health, because of the air pollution. I'm just talking about air pollution, I'm not talking about carbon dioxide. Fossil fuels use water. Many parts of the country are running out of water. If we didn't use coal or gas or even nuclear uses water too, we would have a lot more water left for other things. Renewable energy, like algae and wind, this is a picture actually from Texas, right here, near where I live, they invest in the local economy. People are generating their energy locally. It helps us. Using new light bulbs like this fancy LED light bulb saves us money. They use a lot less energy. We actually, ourselves, can save money. One of my colleagues brought this to my attention. I had not been aware of this. There is actually a death count for how many soldiers in Afghanistan have to die for every ton of fuel that gets transported. What if they didn't have to transport that fuel anymore? What if they had clean ways to get their energy that didn't involve getting fuel from countries that, frankly, many of them are not our friends? This is where our oil comes from. Now, Canada, we're friendly. Mexico, sort of friendly. Look at the rest: Saudi Arabia, Venezuela, Nigeria, Iraq, Algeria, Angola, Russia. That's almost a laundry list of places that the DoD is concerned about. That's where we're getting our energy from. Wouldn't it be nice if we didn't have to? And the best thing of all is it would help us to build a more secure future for our children. Imagine a world where we had clean energy, clean air, clean water, it didn't run out on us, and we were generating it locally, investing in our local economies. What would be the consequences if we're wrong about climate change? The consequences would be a better future. What would be the consequences if we don't do something about it? It would not be a better future. So even just from that perspective, it makes all the sense in the world to consider doing things that would not just help the planet. We're not doing it because we love the earth. We're doing it because we love people. The earth will survive just fine. It's people that we're concerned about that might not. There we go. Thank you.
We now welcome your questions as we enter into a conversation with Katharine.
You can turn on the lights. There you go. Yeah.
Thanks for coming. And I appreciate the part about discipline and loving your neighbor. I had some technical questions about the beginning, more so.
Sure.
So it seems like the marginal difference was human activity, right, in CO2 emission in the earlier slides, right?
Mhm.
So I was just wondering if you had any numbers-wise, if there's any way to tell how much CO2 emission humans give compared to like a volcano eruption. And if the humans are the marginal difference, then how much can reasonably be controlled with actions compared to one more random eruption?
Yeah,
and
exactly.
what's going there. And then the second thing is, I was wondering, I think 150 years for the global temperature averages you said we've been able to record, and like 50 years for rain, something like that.
Well, we do have other ways to measure it going back a lot longer, but that's how long our thermometers, that's how long we've had thousands of thermometers for. But we do have records going back hundreds and even thousands of years, yeah.
Okay, yeah, that's what I was wondering. If that's a sample size, is it reasonable to say that perhaps that's too small for a million-year oscillation or something like that? So those are my scientific questions.
Those are great questions. And actually, let's see. This is the advantage of having your own computer. I'm actually going to see if I have a slide I can show you. That would be cool. Let me see if I do. Yes, I do. Excellent. Okay, here we go. Beauties of the internet. Okay. That is a really good point because volcanoes do affect climate, and I didn't talk about them because there's only so much you can squeeze in 1 hour. But thanks to you, I get to squeeze in an extra slide. Volcanoes, eruptions actually produce a lot of dust that cools the earth. So when a volcano erupts, the main impact of a volcano is to cool the earth for about 1 to 2 years afterwards if it's a really big one. If it's not a big one, it doesn't have a big effect, but like Pinatubo in 1992, all of that dust and ash shot way up high in the atmosphere and it circled around the globe for 2 years. And wherever it went, it cooled down the earth underneath it because it was like this giant cloud of ash. But if you look at smaller, not quite so cool geologic features like fissures, mud volcanoes, volcanoes under the ocean, they do produce heat-trapping gases. They produce carbon dioxide on a pretty regular basis. It isn't a lot, in any one given day, but it's steady day after day, so it builds up. We can measure how much comes out, and when we measure it, what we see is that we produce 10 times more than all the volcanoes in the world, and all the fissures, and all the submarine volcanoes and everything. So they used to be a major impact. Let's see. Yeah, I have it here. This is a picture of how volcanoes cool the earth by reflecting solar energy. Volcanoes used to have a big impact, but right now, again, we've kind of elbowed them out of the driver's seat. So that's the problem we have. Now, I have another picture that looks at our global temperature going back 800,000 years, which is the oldest ice core records we have. They have other sediment records that go back farther, but the ice core is the pretty much most accurate long-term record we have. Let's see, where did that guy go? Don't you love trying to find something? Yes, here we go. Okay. So this is our temperature and our carbon dioxide over the last 6,000 years. You can see we're on a long-term cooling trend until the Industrial Revolution, and our carbon dioxide was quite stable until then too. We can go back further using ice core data. They go down to Antarctica, and they literally drill out this core of ice that's this big around, and it's 2 miles deep. It's crazy. And they slice it because in the layers, every year, there's a layer that forms that has little air bubbles in it, and from the air bubbles, they can tell the temperature of the air. They don't measure the temperature of the air bubbles, they look at the oxygen ratios in it. But they can actually get temperature information, and when they do, this is what it looks like. Isn't that cool? This is our temperature at the bottom now. Sorry, I flipped them. This is the temperature at the bottom, that's carbon dioxide at the top. You can see that we have long cold periods, short warm periods. And right now we're in the longest warm period that we've seen in that record. So remember how I showed you that paper that said that we should be getting an ice age and we're not? This bears that out. Our temperature stayed warmer for a lot longer than it has before, and our carbon dioxide is off the charts. So there's something weird going on. Yes?
Also, could you show on that graph where the ice age was?
The ice ages are the blue ones, and the warm periods are the red. You see how that bottom one is blue and red? So the red is the warm, and the blue is the cold. Yeah. Is that good? Okay. Other questions? Yes?
So what do you see as a viable alternative? Everything seems to have little negative portions to it. Nuclear, has definite problems after the Japan thing. I've even seen articles about PETA complaining about windmills because they're knocking birds out of the air and stuff like that. So, what do you see as a legitimate alternative that could actually be something we could transfer to?
That is the toughest question. I'm so thankful I'm not an engineer because from a scientific perspective, I'm like, that is where my job ends. But it's a question we have to ask have to ask ourselves. And what makes it hard is that there's no one perfect silver bullet that would solve all of our problems. Like in Texas, wind energy is now at the same price as natural gas. So they've gotten so good with these turbines, they put them so high up in the air, and we're making enough of them now that the price has gone down, so it's about the same as natural gas. So for West Texas, wind is a great alternative. Here, you had that whole thing with Cape Cod. Did you guys hear about that? How there was all these environmentalists out in Cape Cod. They were all being all green. Kennedys were out there, and then they're like, oh well, if you're all so green, let's put some wind turbines out there. The screaming could be heard from Boston. They're like, not in my backyard. You're not putting wind turbines. It's like, well, it's a really windy place. I think we should put them there. So there are problems with other things like that. Now, with the bird thing, I actually have friends who research like how the migratory birds go through the wind turbine farms and often get caught in the blades. There's two things there. Number one is they discovered if they paint the wind turbines purple, nothing flies into them because everybody hates purple. At least all the animals do. So that is one possibility, is just to paint them purple. Although I think there's reasons why people wouldn't want to do that. The other perspective, though, is this, and this is the serious perspective, is that yes, wind turbines do have a negative impact on wildlife around there, but climate change has the potential to exterminate up to 30% of the world's species. Like, we're not talking about some birds, we're talking about the species. And so there's some tough choices we have to make, unfortunately. So that's wind. What about solar? I have a colleague who does nanotech, solar technology. His dad's in the oil industry. He grew up in a small town in Texas surrounded by oil. He didn't think climate change was real until like 2 years ago. They knocked on my door one day. He's like, can I talk to you about climate change? I think it's real. I was like, yeah, I think so too. So he does solar nanotech, and he said that there's a huge potential for that in individuals. Like, why are the tops of our cars not with solar panels? Why are we not using solar shingles on our houses? Why don't our backpacks have solar panels on them so we can be charging our phone and our computer as we walk along? So there's a lot of power for individuals in solar technology. One of the main problems with renewables right now is batteries, because the wind doesn't always blow and the sun doesn't always shine. So big investments are being made right now in this thing that a guy at MIT invented, which is a liquid battery. It's made of really cheap materials, very, very cheap. You can make them huge, and that's where the future is, because if we could get batteries big enough to store our wind energy, then when it's not windy, we would still have it. There's also there's tidal energy, there's geothermal energy, there's using fossil fuels in a clean and responsible way. Like, natural gas is way cleaner than coal. So it would be way better to just move off the coal and natural gas. It's really cool and it's really exciting, but it's hard because there's no one perfect thing. The answer is always different. It's kind of like trying to tell every person in the world they should wear the same shirt because it looks good. Yes?
So are you willing to talk about politics and all this?
In a limited sense. What are you thinking?
Because right now, I mean, Mitt Romney basically says, open up all the coal mines in Pennsylvania and let's go. But Obama doesn't come back and say, well, we're trying to make clean coal and really make an issue for that. And, it all comes down to big business and trying to win an election. And I just feel like they're going in the wrong direction, and we're going to be left holding the bag.
Yeah, that's a good point. We are the ones holding the bag, exactly. I think that there's two factors at work. Number one is just the fact that, unfortunately, our political cycle only runs every 4 years, so there just is no incentive for people to think long term. As I said last night, there's a solution to that. Bring back the monarchy. We could probably even negotiate to get Prince William instead of the Queen. Yeah, pretty good, right? That's a serious problem. The other problem is that maintaining the status quo is always easier than change, even if change is cheaper. Maintaining the status quo is easier. And so we have fossil fuels that are so built into our economy with massive subsidies. People don't talk about this, but fossil fuels are massively subsidized. So we do not have a free market. We actually have a market that's very skewed towards maintaining the status quo. So there's a guy called Bob Inglis who was a Republican representative in South Carolina who's very, very, very conservative. I mean, he is proud of the fact that he gets a 0 out of 0 rating on all the Democrat scales. Bob became convinced that climate change was real from his son. His son came home one day and he's like, Dad, you just can't keep saying this stuff. It's not true. Let's sit down and look at the data. So he did, and he realized it was true, but he is a dyed-in-the-wool Republican who refuses any, he doesn't want taxes, he doesn't want all that kind of government intervention. So what he says is, I think, a very sensible thing to try first. How about we just level the playing field? Because this is not a level playing field, it's skewed in favor of fossil fuels. So how about we just level the playing field first, give the market a couple years and see what happens, and then look at if we have to have any more interventions. I mean, that's better than what we're doing now. And unfortunately, there's just this massive silence from our current political leaders on this issue. Just silence. It's a deafening silence. And it's really concerning. And you're right, it makes it seem as if they don't actually have our best long-term interests at heart.
And are scientists also, along with the climatologists, because it's almost like scientists have a bad name and they don't believe anything that a scientist says. I think if you look at the average person in this country, they don't, not only do they not trust climatologists, but they don't trust scientists.
It's tough. Who do we trust? The polls.
We can't even trust our pastors in the evangelical churches.
I know. And it's not only that, but I hate to say this, but Focus on the Family has put out some statements that are extremely negative about climate change. Answers in Genesis has a video about climate change that is so awful that I literally almost had a stroke watching it. That's how bad it was. It just made me so angry. So these organizations who are very trusted and very well respected are putting out false information. And who's going to tell the right information? I don't know. That's what I'm trying to do. I'm only one person. I put my name on the cloning list, but they haven't called me yet. Any suggestions are welcome. Yes?
You mentioned about there being subsidies for fossil fuels, but you also said that wind energy is profitable, or is...
Yeah.
But in fact, wind energy is only profitable because of federal subsidies. My brother is an energy trader for a utility, and he said sometimes when wind is blowing in Texas, actually the energy prices become negative because the people with the turbines are so desperate to get their federal subsidies, they pay people to take the energy they're generating.
Mm-hmm.
So I think it's a misrepresentation to say that wind energy is actually efficient, or is economically feasible. It's not without subsidies.
Right, but the thing is the natural gas is also subsidized, so how about
How is that? How is coal subsidized?
Coal is subsidized through the tax breaks that the companies get. So people have actually done the math, and it's somewhere between $11 to $13 billion a year that they are getting the benefits of. Now, there's also, I didn't even talk at all about the externalities. The externalities are the fact that when we burn coal, it's dirty, it produces air pollution. Who pays for that? So there's all these externalities that taxpayers are paying for to clean up the results of burning coal that are not being paid for by either the people who are selling it or the people who are buying it. So there's a lot of market distortions. And again, I'm not an economist, so I should stop right there because I'm really not an economist or an expert in that. But I think that there's a lot of things that could be done to really make us understand the real cost of all the different energy sources. And so we can make a good, responsible decision as to what really is the cheapest and the safest. Yes, sir.
That bottom graph, does it have a periodicity of something like 110,000?
It does, and this is why it does. Let me show you a cool picture here. There's a reason why it has that periodicity. It's because of this. The Earth's orbit changes in a very periodic way. In fact, you can calculate these changes with algebra. That's how periodic they are. This was discovered by a Serbian engineer, a guy called Milankovic, who was actually interned in a concentration camp during World War I. Now, obviously, the World War I concentration camps were very different than World War II because this is what he figured out with his time in the camp. He obviously had leisure time and a pencil and some paper, and he proposed that the ice ages and the warm interglacial periods are actually driven by periodic and very predictable variations in the Earth's orbit. And in fact, celestial mechanics has proven that that's exactly the case. But here's the interesting nuance here, okay? If we go, where did we put that stuff? If we go back to that nice figure we were showing before, where did it go? Here we go. Okay. So we're down in an ice age, okay? So we're down in that one of those blue areas at the bottom. Oh, this is where I can use this nice laser pointer. Yes, okay. So say we're down here, okay? The orbit of the Earth shifts, increasing the amount of the sun's energy that's absorbed by the Earth. That's what happens. The Earth warms by 1/3. So 1/3 of this warming is driven by the change in the Earth's orbit. Where does the other 2/3 come from? As the Earth warms, massive stores of carbon dioxide that are locked in the ocean and in the land get released into the air as it warms. In fact, some of the ocean stuff, they think they have evidence to suggest it came up in huge bubbles. I mean, I'm talking bubbles bigger than Ithaca. Can you imagine seeing one of those come to the surface? So all of this CO2 boiled up out of the deep ocean in these bubbles. Like, see those spikes? Those are real spikes. That's like 2 bubbles. And this increase in carbon dioxide drove the remaining 2/3 of the warming. So it's like, which came first, the chicken or the egg? And people often say, well, look at this. Temperature came first and then CO2 came later, so why are you worried about CO2 coming first today? Well, it's really both, because the orbit, changes in the Earth's orbit did this much, and then all the CO2 got released, and that did the other 2/3. So it's really interesting. It's interesting historical detection to kind of put all those pieces together. Yes, sir.
Yeah, I guess I would like you to talk a little bit more about just the overwhelming aspect of the problem, because I'm looking at the United States, we're a primary offender here, but then you have countries like China, India, they're rising industrial powerhouses with a lot more people than we have. And so we're at least looking at, we've got to reform our act before we have the credibility to help anyone else reform their act. And we're talking about just 2079 or 2090 with a 10-degree temperature increase. So that seems like a very short period of time to reform our act, get China and India to reform their act as well. So I guess I'm wondering, are there people, I know there's people working on how can we mitigate this in the short term, what can we do now? Are there people just saying it's going to happen, how can we just prepare for it? And I guess, and what kind of things are they proposing?
Yeah, I mean, Miami flew in a bunch of Dutch engineers to talk about building dikes around Miami. And the engineers said, there's no point because you're built on limestone with holes in it like this big. So you just build a wall on top, the water will just go right under and come back up the other side. But in Holland, they're actually talking about, if you can believe it, they're talking about breaking open all their dikes. They're like, why bother holding back the water anymore? Let's just build floating houses. They have entire neighborhoods now that they're building up floating houses. Because they're like, what's the point? Let's just go with the flow. So yeah, there's absolutely adaptation going on. But the problem you referenced, actually, let me just show you here. Our global emissions, these are our global emissions of carbon dioxide. They were growing at 1% per year in the 1990s, but over the last decade, they were growing at 3% per year. Why is that? It wasn't because of the US. US emissions over the last 10 years dropped because we're using more natural gas now. It's because India and China and Africa and South America, they want a US life. Why should we have a car and not them? Why should we have satellite TV and not them? Why should we be able to fly to see our family and not them? Everybody wants the life we have. And so it's a real leadership problem because we've created this desire for a certain lifestyle predicated on fossil fuels, and it's really hard when the rest of the world says, well, how about me too? But we can also get hope because, for example, if you look at China, there's this kind of idea that China's very dirty, and they are very dirty. Anybody who's been to Beijing, you can hardly breathe. Like, it hurts to breathe in Beijing. But in China, the richest man in China is a solar panel manufacturer. China is making more wind turbines than the US. They have wind turbine farms 4 to 5 times bigger than anything we have in Texas. Yes, they are building coal-fired power plants, but they also have their eye long-term because they don't have a 4-year political cycle. So there's lots that other people are doing, but there's lots that we need to do too, and there's no easy solution of it's them but not us, or it's us but not them, or we won't do anything if you don't do it. Well, I won't do it if you don't do it. Well, then everybody loses. And it's really tough. I mean, international diplomacy on this issue is very difficult. And I'm really glad that's not my responsibility too. There's a lot of things I'm glad are not my responsibility. Yes, and then back up to. Yeah, go ahead.
On the question of why people don't believe in climate change. Would you care to comment on the credibility issue with the climate gate, so to speak, and what do you think the effects of that were?
Oh, the effects were huge. They've actually measured the impact in polls. The credibility of climate scientists went down. Let me see if I actually have just a second here. Oh, I do. Here we go. Yes, look at that. If you remember, it was 2 years ago when 10 years worth of emails were stolen from a British climate lab. And what people don't know is that people broke into a Canadian climate lab too to try to steal their computers, but they didn't manage to do it. So that's what happened. So in like 10, I don't know how many thousand emails, I think there's more than 10,000 emails. There's some lines where scientists talk about using a trick to plot some figures, trying to get some papers they don't agree with out of our consensus report, and they have some fairly candid opinions that are not very nice in those emails. Newsflash, scientists are human. So this led to claims that scientists had doctored the data, that the emails disproved global warming, that climate change is a hoax and is not warming after all. But here's the facts. You know about that trick? That was probably the most widely cited thing, the trick they used in plotting data. Here's the trick. The trick is, bear with me while I explain this. This is the data right here. This is tree ring data from northern Siberia. Now the width of tree rings and the density of tree rings usually reflects temperature. If it's warmer, the tree grows more that year. If it's colder, the tree grows less. So what we saw here in Siberia, the thin line on the top is actual thermometer-based temperature, and then the black lines are the tree-based temperature, the black and the dotted line. So what we saw is that in 1960, the air temperature started going up, but the tree ring data went down. Why did it go down? They actually know why it went down. It went down because of air pollution. Air pollution started to stunt the tree's growth. So instead of responding to temperature, now the trees started responding to air pollution. So what was the trick? The trick was, and you can read this email yourself, you can look it up. The trick was, how do I plot this data set but not plot the last 30 years? That was the trick. What trick did you use to plot this data where you didn't show the last 30 years to confuse people because they don't correlate with temperature anymore? Now, this trick, oh yeah, I have this code, I love this code. This trick was published in Nature in 1998, which led to one of my favorite quotes, which you can't see because it's overlapping. Here we go. There we go. This is one of my favorite quotes by Stephen Colbert. He said, climate scientists don't need tricks to hide their findings. All you have to do is publish them in a scientific journal because no one will ever read them. So whatever money they paid the hackers, if they just read Nature, they would have found the trick 10 years ago. So it's really tough because everybody, like even the lady in the supermarket who I talked to in Lubbock, knows Michael Mann and knows that he did something bad. What she doesn't know is that Michael was actually exonerated by 9 independent commissions. 9 commissions in England, in the European Union, in the US, at the university, at the federal level. 9 juries reviewed his work and concluded that he was completely innocent. And so this, honestly, I think that this whole ClimateGate thing is a massive failure of the American justice system because, number one, the scientists were branded as guilty until proven innocent. And then number 2, they were proven innocent 9 times and nobody thinks they're innocent. I mean, what more can you do than go through 9 trials? So it's really a tough thing, and I know some of these guys personally. Shouldn't have knocked my whole thing. I know some of these guys personally, and I know what it's cost them. I mean, one guy went from like a normal, healthy person to a skeleton. He thought about committing suicide, and he just decided not to do it because of his granddaughter had just been born. Another one of my colleagues ended up, his marriage broke up. He had to hire security guards out of his own pocket. I mean, this is destroying these people's lives. And it just is so terrible because, I think my slides are gone for good now. Because they're guilty and nothing they can do can prove them innocent. No commission, yeah.
I think it might be Michael Mann who's suing the National Review for libel.
Yeah, they compared him to Jerry Sandusky.
Yeah.
They basically said he was a molester. Yeah. I mean, that's some pretty bad stuff. It's that. I've just gotten kind of the regular, the unprintable words that people call women type things. But I mean, I've gotten stuff that I've had to file police reports about. I've gotten stuff mentioning my child in a guillotine and what they'd like to see. So yeah, it's serious. There's some people out there who are not nice. Yes. Oh, in the back, you had a question like a long time ago. I never.
I
Yeah.
was wondering about when you do the modeling and you're showing the like a 1.4 degree difference and what becomes a lot later on, how do you know like how strong the negative feedback effects are going to be? Like when the Earth heats up and it radiates more to outer space, it seems like there's a lot of guesstimation and modeling. I did work in a lab for a while that did stuff with IPCC, and it was constantly, they would be like, oh yeah, delete this data point so my model much better. And some of the stuff the professor was telling me wasn't going to be science. So,
Yeah.
like, how do you know how good the model is?
Satellites have been an enormous help to us. So satellites and the last 30 years of warming have cleared up a lot of questions related to feedbacks. Feedbacks are basically, if you have an initial warming of the Earth, there's going to be all these natural factors that kick in to either enhance or diminish that warming. And so back 30 years ago, it was an open question whether there would be net negative feedbacks or net positive feedbacks. A lot of that related to clouds. Clouds are hard to model because cloud particles are this big. And our climate model grid cells are, 100 miles. So you're trying to model clouds this big in a 100-mile grid cell. So for a long time, that was the biggest uncertainty, was clouds. And people even argued, plausibly, that clouds could provide a negative feedback because as it gets warmer, you get more clouds and then they can cool the Earth. But we've had more than 30 years of satellite data now and some pretty significant warming in that time. And that's shown us very clearly that the net effect of clouds is a positive feedback. There's no way you can get around the data. So there's been a huge advance just because of our data record. It's been a big help. You guys had questions?
Yeah, I had a question. I mean, you talk a little bit about public opinion and the swings that we've seen, which kind of drive our politics, and the politics drives opinion.
Yeah.
But there's
talk about feedbacks.
There's a bunch of people who never have believed in climate change, and for whatever reason, you're never going to get a coal industry lobbyist to acknowledge anthropogenic global warming, and also with dominionists, you said we're a group that would not consider stewardship of the earth would be important. But it seems to me that it's a little bit bigger than just dominionists. Mm-hmm. Like when you talk about answers in Genesis, I'm sure you've encountered in Texas and in New York as well, Christians who believe in this apocalyptic strand.
Mm-hmm. Yeah.
If Christ is coming tomorrow, who are we to subvert God's will, etc. So how do you engage such people or views, if at all?
It's interesting you mentioned that because the book that I wrote with my husband, just to give you some background, my husband grew up in Virginia, a Southern Baptist school, didn't think climate change was real. His dad was a Republican politician and lawyer. We met in InterVarsity. We got married. I had just moved to the States. I didn't realize that there was people who didn't think climate change was real. He didn't realize there was Christians who thought climate change was real. We got married. And we had some interesting discussions after we got married. I don't know who was more shocked, him or me. So we argued it through for a couple of years. And we didn't fight, we argued. Because we wanted to still stay married, we wanted to still like each other. And so ultimately, after we finished, that was what sparked our book that we wrote together. And his role was to line out all the questions we had to answer. And then my role was to answer the science questions, and his role was to answer the theology. So that was one of the questions. He said, well, what about, the Earth, the end of the Earth is coming, why don't we just speed it up? I was like, are you serious? We have to write that? He's like, oh yeah, we do. So it's in the book. But basically, I think the answer to that comes from Timothy. Or was it Thessalonians? I'm sorry, I think it was Thessalonians. Where there was people who were like, oh, well, Christ is returning, so we're just going to quit our jobs, we're just going to sit on our rear ends, we're just going to wait for Christ to return. And what did Paul say to those people? He said, get a job, work for your living, and support the poor. We don't know when Christ is returning, so in the meantime, get in gear and actually love people. So I feel like there is a biblical reason to do something. I don't think it's a biblical approach to sit on your rear and say, well, the end of the world's coming, so we shouldn't do anything about it. When it's affecting people. I mean, again, I'm not talking about the planet. Like this whole perception that this is all just about the planet, it's not. It's about people. The planet will be fine. Well, it'll survive, I should say. The planet will survive. Yes.
Oh, yes.
Might look like Venus, though.
Hopefully not as bad as Venus. Venus has a runaway greenhouse effect where it has so much CO2, it has more CO2 than oxygen. So it's, 700 degrees or something on the surface of Venus. Yes?
Yeah, so I guess that sort of falls into my question. I mean, I'm not exactly your clone. I did go to U of T, but
Oh,
I'm not.
well then you probably are.
But yeah, so what can like we do? I guess. I mean, yeah. I mean.
What can we individually do?
Yeah, like what
or
can I do? I guess specifically. I mean, I'm a grad student here at Cornell, but my field is microbiology, so I'm just trying to think like. I don't know, obviously I don't have quite the same clout as you do to go around talking about this to various audiences. I don't know, like what exactly can I do?
Well, I didn't either in grad school, I can tell you that.
Okay.
I wasn't talking to anybody. Obviously, my own husband didn't even know what I was doing, so I wasn't talking to anybody. There is so much that you can do with microbiology because what's going on in the soils and how the soils can act as sinks or sources of methane and carbon dioxide is a big question mark. So I feel like the issue of microbiology and climate change is one of the big unexplored frontiers today.
Well, actually, I focus on like tuberculosis and like
Oh, okay.
immunology, so not
Disease,
really
okay.
soil microbiology. Sorry, I didn't make that clear. But
Whatever our field is a useful field. So it's not like everybody has to like drop everything and go into something that immediately has to do with climate change because you're studying disease, well that helps people.
Mm-hmm.
And climate change could affect the risks of certain diseases, but you're actually working on the disease. So what can we do individually? I think that there's two main ways that we can do things. The first thing we can do is we can actually make changes in our own lives that make a tiny, tiny, tiny difference, but also show other people that it's okay. Like if you buy a light bulb and it's a really cool light bulb, and people are like, oh, well, what's that light bulb? Oh, this is an LED light bulb. I saved $30 this year because I had these light bulbs. And they're like, oh, well, maybe I'll buy one next time I'm at Home Depot or whatever. So like. In our book, we try to do some calculations of, what if every household in the U.S. just replaced one bulb? That would be equivalent to taking almost 1 million cars off the road, which is pretty crazy. Here in the Northeast, we asked the question, how would we get from that higher to that lower scenario in the Northeast? And what we found is for the first 5 years, if everybody in the Northeast who commuted to Boston or New York, if everybody carpooled or took public transit 1 day a month the first year, 2 days a month the second year, 3 days a month the third year. That would be the 5 years of what we had to do. Now after that we'd have to do some more stuff, but we could buy ourselves 5 years by literally just changing our transportation habits. So I feel like there's stuff we can do, but I feel like part of what we need to do is it's about changing our attitudes. Like the one light bulb that I change is literally not going to make a difference to the world, but it's making a difference up here so that next time I hear somebody talking about it, I'm like, you know what, that is something that's important to me. I actually do something about it. So why aren't they doing something? Why aren't the people we vote for? Why aren't the people in our community? Why aren't they giving us better bike lanes? Or why aren't they making it possible to put solar panels on our roof? Like in our neighborhood, you're not allowed to. So I think it makes us more conscious to affect change too. And I know that's not, I wish that there was like a big button we could all just push, like that big red easy button or something, but there isn't. But I think there are things we can do. And so in the book, what I did was I tried to provide like a list of books that I like that have ideas in them. So there are books out there that have some really good ideas. One of my favorite one was like Sleeping Naked is Green. This girl decided every day for a year to do something green, and so one of the things she decided was to forget pajamas because then you didn't have to wash them, then you didn't have to use water and electricity. I'm not saying I did that, but I did some other stuff, yes.
As a minister, to me it was really kind of astounding to see 70%. I went a couple years to an evangelical college, so all right, but that was kind of astounding to me. And I sometimes wonder, does this go back to the fundamentalist modernist controversy 75, 80 years ago that conservative Christians in the United States have a tendency to really distrust science? Why would it be religious leaders, particularly among conservative Protestants, who that blew me away?
Yeah, to speak to your first point, I've actually seen a study, you probably have too, that showed that people who knew more about climate change were more like, the people who didn't think climate change was real knew more than the people who did. So people who did were like, yeah, it's true, well, explain it. Well, something to do with the ozone hole or the spray cans. Ask somebody who doesn't, they're like, oh, those scientists over in England were making up data and the weather stations are wrong and they have all these reasons, so they know a lot. So you're right, it isn't literacy. And I do agree that I think that we're afraid of a lot of the solutions, like that tyranny and no carbon tax slide I showed. Like, I feel like a lot of the solutions actually fly in the face of what America was founded on. And I say that in a neutral, observing way, because Canada was founded on very different principles. But I think that explains some of the resistance. To the second point, I didn't mention this here, but one of the other reasons why I think there's such a strong resistance to climate change among faith communities, especially among conservative Christian communities, is because there is an ancient divide between science and faith. Evolution versus creation, the age of the earth, things like stem cell research and abortion. There's all these issues where science is on one side and Christians are on another. So along comes climate change, and you have scientists saying this, and you have Christian, or you have conservative leaders, they don't have to be Christian, just conservative leaders saying something else. Who are you likely to believe? You already side with the conservative leaders on the age of the earth and evolution and creation and all that stuff. So you're just going to go with them because climate change is complicated. We don't have time to dig into it and figure out, like, if you asked me about stem cell research, I would be like, the ozone hole, spray cans, you know. So yeah, so I think that there is a long historical roots that climate change just fell into that trench that had already been done over the last 200 years. Or it got pushed into the trench.
So where do the Canadians come out in all this?
Well, we have had bills introduced before Parliament again and again. Oh, last question. Great bills, and they have never made it through. We are exploiting our oil and gas resources like never before. Canadians are great on agreeing with the science. Canadians are great on greening our cities. Our cities are quite green. We have wind turbines up in downtown Toronto. We have, you know, recycling, public transport. We have all that green stuff. But in terms of actually doing something at the national scale that would have an impact on the economy, same as the U.S. So that's kind of very discouraging because getting back to your point, I mean, here you have a population that does agree with the science, a population that is making personal changes, right? Like we were talking about, but they still don't have binding legislation. Anyways, thank you very much. Those are great questions.
Cited Katharine as one of 50 evangelical women to watch. And I'm proud to say that with her cited on the same page was our previous Beggs lecturer from 2 years ago, Elaine Howard Ekman, Cornell alum, who teaches at Rice University in Houston. There's a third woman who's cited there who I'm being encouraged to invite for our next Beggs lecture. So stay tuned. Thank you all for coming out on this very busy evening with Trustee Council weekend beginning on this weekend and us having to compete with a lecture taking place this evening involving former Clinton advisor Sandy Berger of the class of '67 and others. But we appreciate your coming out tonight with all of what is going on. Again, we are selling books at the rear for $5, Katharine and Andrew's book. And we encourage those of you who are interested to please purchase a book. And thank you for your participation. Have a good evening.